Welcome to the Selmo Academy tutorial video series. In this video we will show you the functions and how to use the generated HMI. HMI stands for Human Machine Interface and refers to the interface between a human operator and a machine, system or process. Traditionally, the development of an HMI has been a time-consuming and manual process. Selmo has developed an innovative solution to optimize this process. By linking the process model to the HMI generation, the HMI elements are automatically created from the process model data. The advantages of this automated generation are manifold. It saves developers time and effort, improves the consistency and accuracy of the HMI, and enables better collaboration between team members. It will be generated from the process model created in Selmo Studio using the Generate HMI icon. In the output window, you will see the location of the HMI directory. After starting, you will find the following Selmo HMI functions under Plant Control. Global Reset, a global acknowledgement of pending errors. Global Sequence Step Reset, resets all sequences to Step 1. Global Automatic Release, release of all sequences which are ready to start, must be pressed for the defined time of the startup delay. Default is 3 seconds. Language choice for the HMI. Manage Process Set Value Snapshots, provides the option to save and restore all parameters in the HMI. Hardware Zone Control. All sequences of the corresponding hardware zone are displayed in the overview. Each sequence has its own information window in which the current step, the status, and the timeouts are displayed. Sequence Status Lamps. Flashing green, the sequence is ready to be started in automatic mode. Constant green, automatic mode is running. Constant red, a fault has occurred. Call sign symbol. Single step is selected. A timeout is active or an operator input is required. Operating mode selection. Automatic mode. In automatic mode, the system executes pre-programmed sequences, processes, or sequences independently. The gray bar indicates that manual mode has been selected. Here, the machine or function can be controlled manually by human intervention. The green bar indicates that automatic mode has been activated. In this mode, the system works independently according to the preset parameters or rules. Automatic Release enables the automatic operating mode. EOC mode. By activating the end of cycle mode, the sequences are executed up to the EOC step, and then automatic mode is stopped. Sequence Control. To start automatic operation of the sequence, the automatic mode switch for the hardware zone must be activated. If no error or CMZ is active and the waiting for is colored blue, automatic mode can be started via the hardware zone automatic release button. This releases all sequences in this hardware zone. If you only want to release this sequence, you can use the sequence automatic release button. As shown in the waiting for, it is necessary to keep the button pressed for the set startup delay time in Selmo Studio. The default value is 3 seconds. Clicking on the gear icon opens the sequence control user interface. Here you can activate the single-step mode to run the process in a single step. This is particularly useful for commissioning. If the system is in manual mode, the operator can jump forwards and backwards in the step chain to find the correct step in which to start. The next possible step is automatically searched by step next valid. The step information is also displayed in the sequence overview. In the waiting for window, the defined conditions or zones for this step are displayed in order to reach the next step. This enables the operator to recognize immediately which signal is missing and to act accordingly. Manual mode. The zones defined in the Selmo Studio with the HMI button make it possible to control them from the HMI as long as automatic mode is not active. It is important to note that manual mode is only possible if no fault is active. Parameters. This area contains the parameters for this sequence that were created in Selmo Studio. This level is also available for the hardware zone and for the plant. Step time monitoring. When evaluating the time taken by a step, various metrics can be used to get a comprehensive picture of performance. By combining these evaluations, actual, last, minimum, average, max, and timeout count, a comprehensive analysis of the performance and execution times of individual steps can be made possible. This can identify potential bottlenecks, inefficient areas, or issues that need to be optimized to improve overall performance. Timeout. By setting a timeout value, the system can monitor the execution time of a step and check whether it is completed within the defined time limit. If the execution time exceeds the timeout value, the step is considered failed or not completed in time. Timeout add. Timeout additional refers to an additional value that is added to the existing timeout value. This extends the timeout value for a particular step. Suppose you have already set a timeout value of 10 seconds and want to add an additional value of 5 seconds. In this case, the new timeout value would be 15 seconds. Disable timeout. Disabling the timeout or disabling the step time monitoring refers to the process where a function or process has no time limits or limits for the execution duration. Teach mode. Enables the timeout times to be taught by measuring 5 minutes and deriving the timeout from this. System layer. This view shows the system layer as defined in Selmo Studio. Logic layer. Shows the logic layer also as defined in Selmo Studio, with the active step highlighted. This makes active step tracking possible for the operator. Alarm handling. Alarm handling refers to the process of handling alarms or warning messages that occur in a system. It includes the identification, detection, prioritization, processing, and resolution of alarm conditions. When an alarm occurs in the form of a CMZ or DCMZ, this is displayed in the alarm bar and in the waiting for box of the sequence. At the same time, the background color of the waiting for display changes to red, and a red lamp is activated in the sequence overview to signal the fault. In any case, errors must be confirmed with a reset before automatic operation can be resumed. Warnings, on the other hand, are only displayed in the alarm bar and are highlighted in orange. These warnings have no influence on automatic operation. Click on the alarm bar to open the alarm overview on the HMI. Faults and warnings are displayed in the alarm list as long as they are active. All relevant information about the alarm signals, such as type of fault or warning, time of occurrence, and any assigned information, is listed here. The alarms that have occurred are logged and saved with a timestamp in the alarm history. All past alarm events are recorded and sorted chronologically. This allows the alarm history to be used to subsequently analyze and trace past alarm states. Hardware zone status lights. Any sequences ready to start shows whether a sequence in the hardware zone is ready to start automatic mode. All sequence ready to start indicates whether all sequences are ready. Automatic lamp. Flashing means that at least one sequence has already been started in automatic mode. The rest are waiting for the release. Steady light indicates that automatic mode is active in all sequences. Safety gate lamp shows if the safety gate switch is activated. Emergency stop lamp informs that an emergency stop is activated. EOC reached lamp flashes when the EOC mode has been activated. If it is permanently lit, this means that all sequences in the hardware zone have reached the EOC step. Lamp test indicates whether any of the indicators of the control panel are not working properly, and whether the characters displayed in the function data display of the control panel are valid. In the next video, we show an application example for beginners with the demo drilling device.